Guys, Miss Smith here with Module 4 of 3rd grade Eureka Math for Tennessee. This is the Topic D quiz covering area of rectilinear shapes. So we're just going to dive right in. Question number 1 says draw a line to decompose the shape into two rectangles. Then label the side lengths of each rectangle. So basically, a rectilinear shape is when you have rectangles that have been put together to form another shape. In this case, they want us to break it apart into rectangles, two rectangles. So if I look right here, I could snap this off and it would be a rectangle, and this other shape would be its own rectangle. They want me to label the side lengths of each of those that I have shown are rectangles because I don't know how necessarily to find the area of a rectilinear shape. I do know how to find the area of a rectangle and then put those areas together. So I have a length of a side that is 2 units by 1, 2, 3, 4 units. So that one is a 2 by 4. This one is a 1, 2, 3, 4 by 1, 2, 3, 4. So all I needed to do was draw to show where you would decompose or break those two rectangles apart and label the side lengths of each. Number 2 says Gabe has a rectangular piece of paper that is 8 inches wide and 9 inches long. He cuts out a rectangle that is 3 inches wide and 5 inches long. So if I look here at the bottom, I see that this length is the 8 they're referring to. 1, 2, 3, 4, 5, 6, 7, 8. So I have a side that's 8 inches. And then I have a side that is 9 inches. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have a 9 by 8 rectangle, or 8 by 9 rectangle. However, he has cut out a piece or removed a piece. So one of the things that we talked about is when we have a problem like this, we can first find the area of the whole rectangle. So I would need to solve 9 times 8, which equals 72 square units, or square inches in this case. However, he cut away some of that. So I need to then find the area of the piece he cut away. They told me this piece was a 3 by 5. So he took away a 3 by 5 piece, or he took away 15 square inches. Okay, I can't take away 5 if I only have 2. So I need to get some 10s. I'm going to take a 10 from my 70 and put it here. That gives me 12. And it leaves me with 60 over here. 12 minus 5 is 7. 6 minus 1 is 5. So the area of the rectilinear shape that was left was 57 square inches. Looking over here at my choices, 57 square inches. Also have another shape that is rectilinear. It does not have the grid, however, but it does have sides labeled. So I have a couple of choices. I can make this entire rectangle, fill it in and make one whole rectangle, and then subtract the part that's remaining. Or I can draw in some pieces to make separate rectangles. So I'm choosing to draw in. I have a big rectangle now, just by something. It's not 6 centimeters by 7. It's not 7 centimeters anymore, excuse me. So I have cut this side, which was 7 centimeters, into a smaller piece now. So I'm going to have to come back and figure out how many centimeters that is. We'll talk about that here in just a second. I have another little rectangle right here. They have labeled those sides for me. So I have a 3 centimeter by 2 centimeter rectangle. So I'm going to go ahead and write that area over here. I'm going to write that I have a 6 centimeter by something. We don't know what it is yet, centimeter. And then I have one more left up here, a little tiny rectangle. And it is a 1 by something. Okay, so I have a 1 by something, a little rectangle. So the next thing I have to do is be a math detective, and I have to think about how can I find the missing length. One of the things we have talked about as far as attributes of rectangles, if I know one side's length, then I know the opposite side's length. So if I look at just the orange rectangle, I can see this side at the top is 3 centimeters. If this side at the top is 3 centimeters, then this piece down here at the bottom is also 3 centimeters. I know that this whole side is 7 centimeters, and I know that a piece of it is 3 centimeters. 3 centimeters plus some more would make 7 centimeters. I would need 4 centimeters to make a 7-inch side there. 4 centimeters plus 3 would make that 7 centimeter side. So I know the first one is a 6 by 4. Okay, looking up at my yellow rectangle. Okay, just the yellow. Down here, I had a side length that is the exact same as my yellow. If this one is 3 centimeters, then this one is also 3 centimeters. So I have a 1 by 3 centimeter. 6 times 4 would give me 24 square centimeters. 3 times 2 would give me 6 square centimeters. And 1 times 3 would give me 3 square centimeters. These are all areas of this rectilinear shape. I just have to put them all together. So now I'm going to add those parts together. I have 4 plus 6, which makes 10, and then 10 plus 3 more, which makes 13. I have 3 here, and the teen or the 10 right there. 2 plus 1 more 10 is 3. So this rectilinear shape, the area was 33 square centimeters. Number 4, Oka's bedroom wall is 9 feet long and 9 feet wide. I'm going to go ahead and draw myself a bedroom that's a square as best as I'm able. So Oka has a 9-foot by 9-foot bedroom. Then it tells me she hangs a poster on that wall that is 4 feet long and 3 feet wide. So I have a portion of that that is 4 feet long and a portion that is 3 feet wide. So I'm going to hang it. I just chose to hang mine in the corner. This is her poster. Her poster is 4 feet long and 3 feet wide. The next question asks, what is the area of the wall not covered by the poster. So basically, I have made a rectilinear shape. This backwards L type of shape is the shape of her wall that they would like me to find the area of. So again, I can use what I know to solve for this. I'm going to make a portion of her wall that's a rectangle here. And I'm going to make a portion of her wall that is left. I'm not counting this area because they have not asked me to find the area of that part of the wall. They only want the part not covered by the poster. Okay? If I'm doing it this way, I have to find the lengths of these sides. I know if this side is 9 feet, then this side is also 9 feet total. 3 plus 6 feet would make a 9-foot space. So this portion of the wall is 6 feet. This side is 9 feet. If this side is 9 feet, then the opposite side is also 9 feet. So my orange space of the wall is a 6 by 9. Looking at the blue portion of the wall, this portion was 3 feet, which means this portion is 3 feet. This portion is 4 feet, and the whole wall is 9 feet. So if this portion is 4 feet and the whole wall is 9 feet, this missing portion is 5 feet. 4 feet plus 5 feet would make the entire length of the wall. The blue rectangle has lengths of 5 by 3 to help us find the area. So this shape that is not covered by the poster would be 15 square feet. And 54 square feet. I have to then put those two things together to give me the total area of those spaces. I have 4 plus 5, which makes 9. I have 5 plus 1, which makes 6. So the area of this entire space was 69 square feet. Okay? I could also attack this problem a different way if I chose. Instead of decomposing it into two smaller spaces, I could find the area of the entire bedroom wall. The entire bedroom wall was a 9 by 9, which is 81 square feet. The poster is a 4 by 3, which is 12 square feet. I could then take away the portion that does not belong to this shape, that's the poster, from the 81. I can't take 2 away from 1, so I need to take a 10 from here. That leaves me with 7 tens, and I have 11 over here. 11 minus 2 is 9. 7 minus 1 is 6. Either way students solve it, whether they are getting the whole area and taking away the part from the shape that doesn't belong, or they are finding smaller areas and putting them together. Either way is perfectly fine. Stay tuned for part 2, question 5.